Hi there, welcome back. Okay, this next session, which I haven't got up yet, is going to be all about networking, mobile services and authentication. I love talking about this stuff, so I've got this like 3 hours of content I've had to cut down to 45 minutes, which is tragic, frankly, but there's loads of real cool stuff, and so I'm going to get straight into it because I have got a lot to talk about. Networking basics, what everybody should know and thinking about networking. I'm then going to do a nice demo showing the great tools we've got in Visual Studio for working with Azure mobile services. Then have a quick look at background transfer service, down to the HTTP client if you need to really get down and make direct HTTP calls, and then going to wrap this one up with looking at authentication. Specifically, well, a little mention of Credential Locker, which we looked at yesterday because it's relevant in this context. But what this is really about is the Web Authentication Broker. So, the first one of them, the basics about networking. Okay, the thing is, and like this is like, really, dirt, you're telling me this? Mobile devices are not always connected. Now, it's worth mentioning this. People forget this, even though everybody uses mobile devices and everybody knows that you haven't always got good Wi-Fi, you haven't always got a good cellular signal. You know, so you have to remember about this when you're building apps, and also app developers spend their whole time probably doing software development on PCs that have probably got a pretty good network connection, because you set yourself up in an office with that and you cannot work without a good network connection. And you're kind of building software on an emulator and you forget that when it's actually being used, you may not have a good network connection. And although mobile networks are getting faster, you know, 4G is being rolled out, LTE, and it's all really cool, the reality is that that high-speed connectivity is only available in pockets here and there. And if you live in like the mountains, like I do in North Wales, well, if you get a real fast network connection, that's a rarity. So enjoy it while you've got it. But you need to build apps that work well, if they need a network, that work well in a wide variety of network conditions. And you've got to think about the costs of using those networks as well. A lot of users obviously are very cost sensitive in terms of the amount of data that's going across the networks and how much money it's costing them. So you need to be aware of that. Give your users choices about whether to only do transfers when they're on Wi-Fi, and making sure if you are doing network transfers, you keep it as compact as possible so you're not costing them money. And think about caching data, and think about the startup experience of your app. You know, the last thing anybody wants to see is they start up an app and the first thing they have to do is watch a progress bar while we're saying, hang on, we're just getting some data over this really bad network. And that's going to be a bad user experience. So think about these things and make sure that you're being a good citizen and giving your users a good experience. We've got some capabilities which are relevant. I'll just mention these up front. On Windows, there are 3 different flavors of it. The Internet Client, which is required for outbound traffic, Internet Client and Server, which is peer-to-peer, and then private networks when you're on a private home or work network. Those are all rolled into one on Windows Phone 8.1. It's just Internet Client and Server. So if you need to use a network, just make sure that you've requested that capability. And when you're thinking about building in networking capability in your apps, don't kind of reinvent the wheel. Don't go right down to the bits and bytes unless you really need to, because there are lots of higher level frameworks and abstractions you can use that make your life much easier. Azure mobile services are going to look at in a moment to easily build a cloud backend, and Azure Notification Hubs makes it really easy to send notifications from backend services to multi-vendor clients. So not only our clients, but also to iOS and Android devices and to web clients as well. It makes it really, really easy. So use these services. And the background transfer service for download and upload of files, which we're going to have a quick look at. Web Authentication Broker is a great component we're giving you in this release, which makes it easy to do OAuth 2 authentication against internet social networks. And the HTTP client is there, and it's a really rich API for when you need to make those direct calls. This is a complicated table of all of the different APIs we've got. I just want to call out a few things there. We've got HTTP web request and HTTP client. HTTP client there's 2 flavors of it, system.net and windows.web. The windows.web one is the one you want to use. It's better than the system.net, which is the kind of older, now almost deprecated, if you like, .NET API. And we've got a couple of convenience APIs, Syndication Client and Atom Pub Client, which make it easy to read content from those kind of sources. And then when you look down to the web services, there's one big thing you have to call out here, is that WCF Windows Communication Foundation APIs are not supported in WinRT apps, Windows Runtime Phone apps. They are on Windows Store apps for big Windows, but they didn't make it into Windows Phone. So it was one of those features that, yeah, sure, we'd love to have put it in, but had to be cut in order to hit the ship date. So if you have already got legacy, you've got WCF services out there that you want to access from a WinRT app. So just be clear about this. You can still access them fine from a Windows Phone Silverlight app. But if you want to build a Windows Phone WinRT app, you need to access legacy WCF services. Then you might have to think of putting a REST service facade out there, which acts as a gateway that you can call first, and that in turn makes the call onto your WCF services. So those are the APIs. Okay, now the first kind of proper topic, if you like, of this after the intro is I want to have a good look at Azure Mobile Services. Well, actually, a very brief look, because again, this is one topic that you could easily spend a whole jumpstart on. It's a really cool system, but I'm going to introduce you to it, in case for those of you who haven't come across it before. What is it? It allows you to easily build and host a mobile backend in the cloud. And it's completely cross-platform. So we support iOS, Android, HTML5 clients just as well as we do Windows and Windows Phone. The code backend, your scripts in the cloud, it can be in C# or it can be in Node.js. And it's got great support for push notifications. We've got enterprise single sign-on. You can authenticate against social networks such as Facebook, Twitter, or Google. And your backend database, so behind all this there'll be some kind of a database. That can be SQL Azure, or it can be Oracle, SAP, MongoDB. You can scale it out to millions of devices. This is a proper cloud service. It actually comes with an enterprise-grade service level agreement. It's a really, really cool offering that you can use to build out your backend. So there's got great tools in Visual Studio 2013 which you can use to create the Azure mobile service. Now, you can go to the Microsoft Azure portal, which is at manage.windowsazure.com. You need to sign up for a Windows Azure subscription. And you can create all your services in there, obviously. You can do all the stuff that you like in the Azure portal. But there's now great tools built into Visual Studio that help you to do a lot of that work from within the dev tool. So you can right-click on your project and say Add Connected Service, and then this puts up this dialog. I'm going to show you this in a minute, so I'm not going to talk through this too much. And this allows you to create or connect to an existing Azure mobile service and create a new one here. And it adds all the correct references to your project and plugs some code into your solution to make it so it's ready to go to connect up to that new cloud service. And from within the Server Explorer in Visual Studio, you can go and look at your tables and create new tables up in the cloud, and you can edit the scripts because it creates some scripts that are associated with each of the CRUD operations: create, read, update, delete, and you can edit those whether they're Node.js or .NET, C#. You can edit those directly from Visual Studio. So you've really got great control right from within Visual Studio for all of these operations. And then you just write some code to interact with it. So it gives you a client object. At the top line of this method where it says iMobile service table to do item, to do table equals app.taskmaster demo client. That taskmaster demo client is an object that when you subscribe to the service, it added to your app class, which is a proxy class you use for interacting with your mobile service up in the cloud. And you can create objects in your own code and then simply insert them into a table. And we're going to do all that in the demo. You can also really easily configure the whole thing up for push notifications and do all of the steps you need to do both on the client side and the client app, and also configuring the backend service. Again, all from Visual Studio, so it's very, very powerful. Now, before I go to the demo, that is just the slimmest little touch of what you can do with it, because Azure Mobile Services It can really easily add authentication. So, and this is important, obviously, if you're storing all the data in the cloud from all of your clients, and hopefully you've got thousands of clients running your app, you need to separate each client's data. So they need to authenticate, and then you can actually record against each object that gets created up in your tables in the cloud who actually who created that object. So you're partitioning that data by user. You can customize the scripts that are associated with create, read, update, delete. You can implement scheduled background tasks running in the cloud, so that you can have some background logic that's running frequently and can be looking at doing some back-end processing and looking for things that are relevant to your application scenario. But almost the most important point is, up till now, everything has had to be online, which for me has been, well, it's interesting, but like I said at the beginning, in the real world with connectivity not guaranteed, an online-only solution is only of limited interest to me. But now they are bringing it out. It's still in it's only early adopters, so this is a preview at the moment. They're looking at offline support. Demos are out there for Windows clients at the moment. You can go and search for them on the web for offline support, and that will be coming for Windows Phone 8.1 in the near future. Now this is really cool because this means that we've got a SQL-like database on the client, and when you pull data down from the cloud, it's stored in that database, it's cached, and thereafter your client app can carry on working against that cached data, which allows it to work offline. And then when you get a connection again, you push those changes back to the cloud and you're connected again. This is really cool, and this makes it...
It's so cool. It's really exciting.
Okay, let's show you the Visual Studio tools, how this works. This is the portal, by the way, to start with, the Azure Mobile Services portal, where you can create mobile services. I could go down here and I could create myself a new mobile service, but I'm going to work in Visual Studio. Now I've got an app here. I'm going to run it first. It's not hooked into the cloud at all. It's just a dumb client, if you like. This homepage actually will show a list of tasks that you've entered into this Task Master app. And when you hit the plus on the app bar, it takes you to a new page, and you can put some stuff in. You say something like, "This doesn't work yet," or something like that. So we do that, and then you can assign it to Andy. Let's go to that keyboard. It's kind of annoying. Down. There you are. Thank you. And then you can save it. Except save doesn't actually do anything at the moment because we haven't put the logic in. And there's no tasks. So okay, that's the deal. Now I have to know, obviously the app kind of understands tasks, and in my data model I've got a class called task item. These are the objects I'm going to work with in this app, and we've got 5 properties on this object. ID column, we've got a title, description, due date assigned to. Those were the entry fields, data entry fields you saw on the page there when I was trying to enter a task. This is our model that we want to store in the cloud. Okay, let's get going with this, and let's start connecting this and build ourselves a mobile service. So I'm going to right-click on the project up here and go down to Add, and in the Add menu, there's Connected Service. So this is going to bring up the wizard, the Services Manager. Now, ignore Jumpstart to do live there. That actually one I created 18 months ago in the Windows Phone 8 Jumpstart, when I did a preview of Azure Mobile Services, which was just coming out at that time. So that's a really old one. I want a new service, please. I'm going to choose. I've got 2 subscriptions to choose from. I'm going to create. This one is going to be called Jumpstart Demo. .azuremobile.net. The runtime is whether I want .NET Framework on the back end or JavaScript. I'm going to choose JavaScript. Region, let's create it in North Europe. This is where it's going to be hosted in Azure. And I've already got a database. I've created a SQL Azure database. So I'm going to use that one. I'm going to put in my password for that. And it's creating that service. And we wait a minute. This is just the same as if you did it through the portal. So it's building it in the cloud at this moment. It's hooking up the database schema. It's creating some REST services for this service up in the cloud and spinning up the kind of web worker roles. All this is a packaged solution. You could build all the bits of this yourself out of in Azure if you really needed to. But that's why this is kind of a software package as a service kind of thing. It's a ready to go back-end mobile service you can use for your apps. Still chuntering away. It will take a few seconds. It always does, and it's taking a bit longer than I feel comfortable about. Come on. And then, so it's building this out in the cloud, and in a minute, wait, there we go. We've got our service has been created. Now, when I hit OK, it's adding it into my solutions, and now this is where it's integrating my client app, this app already. Now, what has it done? It's added some references. So we've now got some references for Microsoft.WindowsAzure.mobile and WindowsAzure.mobile.ext, and it's added some other stuff for HTTP extensions. So we've got some new class references, and it's also added into my app.xaml.cs some code. It's added in this. This is my proxy object, which I use for, this one is going to be my object I'm going to use to interact with this service. And it's also already hooked up the address of my service out in the cloud, and this is the key, the client ID that you need to specify. So it's already done all that kind of stuff for you. Now, we go over to this Server Explorer here, and here's a Windows Azure. We can expand this out. You see mobile services here. You can actually go into look at everything that's in Azure. And there's my old service, and any of your services will be listed here. So this is my Jumpstart demo one. There's nothing actually in it yet. It's just an empty service. So what we're going to do in here is create ourselves our first table. So I'm creating a table. I'm going to call it task item, which spookily is the same name, of course, as my model that I've already created in my project, the task item.cs I showed you before. Let's create that table. Let's creating that up in the cloud. And when that is created, it's off to the cloud. Now, again, you can do all this in the portal. Now it's refreshing in Server Explorer. And now we've got our table. And if you expand that out, here are the scripts which are, for example, on an insert, we've got this JavaScript, which is pulling down now from the cloud, which actually just simply, there's no code in here at the moment, just executes that request. You can customize these in Visual Studio, but we're not going to. We're just going to leave it like this. Now, actually, one thing, I will just go over to the portal. I want to show you something. So here's now my new service has just been put on here. We can go off and look at the data in the portal. And we've got this task item table that we've just created. If we look at the bit more detail of it, obviously it's got no data in it at the minute, but the columns it's got in it, it's got 4 columns that it's created for a new table. First of all, it's got a primary key called ID, which obviously is really important to identify each record in the table uniquely. And then it's got 3 columns: created at, updated at, and version. These are versioning columns, that the metadata, if you like, that it's already put in, which is to support all the data synchronization, the offline working that I was talking about. That's why those are there. So don't delete them. They're important. They're used by the framework. But you'll notice we've got ID, but remember how this object has got all these other. Sure, we've got an ID column in our objects we want to store up there, but we've got these other ones: title, description, due date, and assigned to. How do we get those into our table in the cloud? Well, this is one of the really cool things about Azure Mobile Services. And during development, it has this idea of a dynamic schema. So all we need to do is to get one of these objects and serialize it to JSON, send it up to our service, and the Azure Mobile Service will automatically configure that table, add columns to it, to dynamically expand the schema to support whatever you send at it. Does mean you don't want to send any rubbish up at it, of course, as well. But this is really cool. So that's what we're going to do. So let's add some code now to the project in order to do that. Go over to main page. This is our main page, which shows the list of objects. So I'm going to put in a little snippet of some code that I've already got for this, which is JMS get tasks. There we go, get task items. What we're doing is we're going to call our jumps. This is the object that it created for us. We're going to get the task item table. We're going to get all the items that are in it, and that will return us a list of task item. And then what we're going to do with that list is put that as the item source of a list view, which is the list of objects on our main page. And of course, we need to call that from somewhere. Let's go into, well, let's put it into navigation helper load state. Let's put it into there, which runs when we come into that page. So I'm going to call that new method that I've just added, get task items in there. Now, of course, the first time we run that, there won't be anything, but now we're hooked into the cloud. We're going to pull items down and display them on the screen. So the next thing I want to do is actually put the logic into insert into the cloud when we create a new task item. So when that plus button on the app bar is hit, which at the moment it didn't do anything. The reason why it didn't do anything in it because we haven't got any logic in it. So let's fix that. First of all, let's add another method here. Now this is going to insert task items. So I need to fix up some references. Into Azure Mobile Services, and now we can call that when we're on the save button here. So we can say await, which I'm going to call an await function. So let's put async on there. And there we go. Await. Insert task item. And that's going to insert it into the cloud, that method I just. And then we also need to go back, frame.goback, having done that. All right, so now we can run this and see if it works. No tasks come back, but let's add one now. Azure Mobile Services rocks. Oh yes, it does. And yeah, due date, and we'll assign it to me. And we're going to add it, and there it is, and it's gone. It's up in the cloud. How do I know that? Well, let's just prove the point. Let's browse up in the cloud, and there we go. AMS rocks. Oh yes, so it's up in the cloud. So that's how you add a record, add stuff into there. Now the next thing we can do is so that's pretty cool. That's good starters. And what about adding some push notifications to this as well? So we go add push notification. So we get a big window. It says before you begin. It just tells you what it's going to do. It's going to associate the app with the Windows Store. Now you can do all this with directly from Visual Studio, but it's going to do that for you. It's going to add some code to the project for sending the push notification channel URI up to Azure Mobile Services. It will modify the back end to enable it to send push notifications through WNS, and it will do some stuff with redirect domain URIs. So let's just go ahead and do that. Now I have to sign into the store, so I have to sign in with my Microsoft account, which is this one. And add in my password. And then sign in. Now, at this point, it's going to email me a link, or you can send it by a text message. So I'm going to send it to. This is like two-factor authentication. So it'll send it to an account, and somewhere I've on my tablet here. I'm going to wait for this to come in. It's come. Oh no, that's my climbing Supertopo climbing news. Just got a new email. It's not the one I wanted. We're waiting for the new one to come in. Come on, baby. Come on. We might have to come back to this.
You're a braver man than I. I have this.
What, email? Yeah, well, I did try this morning, and it did work. Like bang, it was straight in.
Yeah, no. I've had the code come in very quickly, but when doing demos, I'm always so nervous about
I know,
two-factor and.
Yeah, I know.
Wow.
Yeah, well. Yeah, we're still waiting. It's coming. Thank you. So I need to open it. That right. So I've got a code which is 3288. Read this 4841. So we've authenticated. It says, yeah, you are who you say you are. It's checking the developer account. And now this is how you associate your app with the store, which you're going to have to do anyway before you publish any app. There's some apps I created, lots of cocktails apps. You can create a new app name, or we can use one that we reserved before. I'm going to use one I reserved before, and nobody else has got Jumpstart Demo 001. And now it's find out what services you've got. Which one do you want to use? So yes, let's do the one we just created. So you go next. Now it's going to tell us what it's going to do. It's going to add some more references, add some more code, and update the mobile service. So let's let it do that. It's doing loads of cool stuff. It's setting up push notifications in the cloud. It says this may take several minutes to complete. I sincerely hope not. And it's creating a custom API which allows you to call push notifications as well. Yeah, there we go. So what it's showing us here is actually it's showing us in Server Explorer. It's added a new script, notify all users.js, which is on the server side, and this has got a function you can call to send a notification. And the default is just to send a little hello world notification. And it will do that. Actually, also it's added a class into my client-side app. This is in the mobile app. It's a method called upload channel, which registers your app with push notifications, gets the channel ID, and then sends that channel ID up to the cloud, which registers your client with the push notifications on the back end. And then it also, just for good measure, just to show it all works, it invokes that custom function. So we should get a toast coming back through a WNS when this has all happened, just as a verification to us, a confirmation that it's worked. So, and the other thing, of course, it's done is it calls that method. It's stuck another line on the end of my onLaunched, hopefully. Yeah, there we go. It's stuck that in as well. It's calling Taskmaster Jumpstart Demo Push upload channel, which is that function I just showed you, which is added to the project. So if we do that, when it launches, it will register for push notifications and send its channel ID up to the cloud. In a minute, we'll get our list of notifications down from Azure Mobile Services again. Yes, there we are. That's the one I entered before. And it's also got a push notification channel, which is sent up to the cloud. And we should get a notification in a minute, which will say hello world, just confirmation that that has all happened. Go on, don't let me down. So that's still thinking about stuff. Okay, and then it didn't work because the timeout period expired. It was trying to send it up to the cloud, and every time I have tried this before, it has worked. But now, live in front of the cameras, it's let me down. Thank you. Okay, well, I haven't got time. We might try it again later, but trust me, you obviously need some try-catch around that. There's the message of that in order to handle this in a real app. But if you do this, it is reliable and does work. So, but I'm going to move on because we've got too much to talk about. All right, that was a quick intro. Loads more stuff you can do with Azure Mobile Services, of course. So have a look at it. It's a really cool way of building out your mobile backend. And like I said, it is cross-vendor as well, so you can support if you're building a mobile solution with different kinds of devices on it. Android, iOS as well. Yeah, we can support them. And
there are sample projects for everything under the sun. Website, iOS, Xamarin, Android, everything. They're just kind of like, hey, use our service. Here's a pile of code. Yeah,
they do a really great job of step-by-step tutorials to help you do all kinds of, and it's much more sophisticated than that trivial little demo.
It's fun and it's almost magic when you try it the first time. So. Yeah.
Right, a quick look at background transfer service, because again, in the idea of abstraction, mobile services that, things that make life easier for you as an app developer. If you want to send a file to the back end or upload a file from your back end servers, this is the way to go. You could write some code in HTTP client and handle it all yourself, but why bother? This is given to you on a plate. It's a power and cost-friendly API for doing that sort of thing. It allows you to do parallel or serial file transfers. You can have transfer groups. It's also got some nice features for updating tiles and sending toasts when a transfer is completed. So you can just set properties to do that. You don't have to write any code to do it. And it also, the cool thing is, it actually knows all about expensive networks and will automatically switch to cheap networks. And so it's kind of cost-friendly as well. easy to use. So this code here, the actually important bit is there's a couple of things in here. So reading down from the top, first of all, we create ourselves a cancellation token source. This is something you use with async long-running operations to cause a cancellation of it from your foreground app. And then we have a storage file, destination file. We're using the known folders to get us a file from the pictures library. This is just an example of something you could send, okay? Now, you new up a background downloader object, and then on that object, you call the create download method on it, which gives you back a download operation object. And then you just call download.start async. Which starts the operation. This special form of it with .as task allows you to send in that cancellation token source, which makes it cancelable from your foreground app. If you don't have that, it's just fire and forget. Let it get on with it. And then there's also you can have a progress callback. So those last two bits of it are entirely the .as task is entirely optional. You can just set it off and then away it goes. And then you will get your task cancelled exception or exception if the user cancels it. So that's the kind of the deal. If you cancel it, well, you just call the cancellation token source.cancel and then dispose of it. So you might put that on a button in a foreground app to say, okay, cancel that. But the key thing, of course, is this is all happening in the background, and if you want to get some progress reports from this thing that's going on in the background, download progress is an event handler for the getting progress reports from it. But you don't have to have the foreground app running. You can have it. The foreground app could be suspended, and the OS will just take care of completing that background transfer for you. I'm going to show you a very, very quick little demo of this. Get the right key. Right, there we go. And actually, what this demo is it's actually the SDK sample, because and I've got two motives for this, because I wanted to show you one of these samples because they are universal, just to drill home the fact that all this stuff works on both Windows and Windows Phone. You get a Windows head and a Windows Phone head in it, and then in the shared area is basically all of the stuff, all the logic. So there's download, upload, and notifications. The download one is basically kind of a more extensive version of what I showed you there. But the important thing is this one. Let's go to that method, go to the definition of that. This is where we actually set a progress callback, and then we call that download.start async on our downloader. That starts it. Or you can if you run up your foreground app and there's a downloader already going, you can attach to it, because so you can enumerate the background tasks that are running. Two little quick examples of that. First of all, file download, and just look at this wonderful UI. Somebody didn't do a really great job on this, I'm afraid. Look, this is pretty horrible. Buttons extending off the end. This is because this was a quick port from the Windows version. Just to show you that you need different UI on a phone compared to Windows. But we've got, what's this? This is where our background service is. Background transfer sample. It's a website running on the in IIS. If I just go over to IIS Manager. Go and have a look at my Internet Explorer IIS on here. Default website. Here's my background transfer sample. It's running on my dev box. So what's weird about this?
It's the local host. You're not calling out to an external service.
No. Those of you who have ever built anything networking for there we go. I'm just going to let that run. It's running in the background. We're getting progress reports. Yeah, anybody who've done anything in Windows Phone 8 will know that you cannot call a localhost service from an app running in the emulator and get it to work out of the box. No, it'll never work.
Right.
It'll never work. You've got to have the host name. You've got to open firewalls. You've got to do all sorts of security stuff.
It is a task and a half.
It is. It's documented, but it's not fun. That's completed, by the way. and while we're at it, I'm going to show this completion notification. You can do 3 downloads from previous, so we can start 3 downloads and show toast on completion, and that will start 3 different downloads from our website running in my IIS, and then we'll get a toast when it's done. Yeah, so the localhost is really cool because it means it's super easy now to create anything that's connecting to a service, have the service running on your dev box, and test out the app running in the emulator, and it all just works. It's so cool. And we should why is this not? Oh, I must have hit a breakpoint. That's why it's not running. Oh no. Is it? What's going on?
So did you check the Action Center? Because the toast might not pop up if you're in the foreground.
All 3 downloads completed. Ah, thank you so much.
No problem.
Yes.
We'll cover that in the next session.
Actually, I want to show you one other cool thing in the external tools here. Look, on the network tab, we can simulate different quality. Oh yeah, it does come at the bottom. There you are.
Oh, okay.
I knew it did something. 3 down, and we got the toast comes up. You know, it's just slow. Then you can simulate different network speeds. So we can go with 3G. We can simulate. It's because I meant to uncheck that. I was actually on a 3G network. That was why. So it was kind of slow. And if I do it much quicker, you turn off the network simulation and run it. It goes pretty quickly, like at warp speed. Yeah, there we go. So, but yeah, you can turn on network simulation and do it again. And actually, before I do it, let's put this back into normal orientation because that's making me feel seasick. Start another 3 downloads, and then obviously we can come out of the app. We can even suspend it. Like, terminate it. Let's terminate it. And chuntering away in the background, the backward transfer service will still be doing its thing, and we should get a toast come up in a short while. Did it come up already? Oh, I think it might have done, because we've got 4 of these guys now. I don't want to see that date time thing anymore. So the background service is still running, would still run in the background even though the foreground app has been terminated. All right, moving swiftly on. HTTP client. This is one of those APIs that it's super simple to use and also super flexible, so you can get it as complicated with it as you like. This is where you actually need to make HTTP calls to maybe to a REST service. You're not using the beauty of Azure Mobile Services or something like that, so you haven't got a proxy object. You need to get down and dirty and code right down, craft your HTTP request yourself. This is the simple way of doing it. You new up an HTTP client. You can set some request headers. This is really nice. There's this strongly typed request headers now. So you can do HTTP client.default request headers.accept, or all the kind of other headers as well. .try_parse_add, and it will check that the string you're passing in is appropriate for that header. So that's a nice way of avoiding errors in setting headers. And then you can, if you want to get a string, like it's a service that returns JSON or XML or something, you can just call HTTP client.getStringAsync. That's it. That's as simple as it is. We have got, I mentioned this before, there are 2 HTTP clients. The old one is system.net.http.http client, which was the only one available in Windows 8.0, and it is also available through NuGet packages for Windows Phone 8 and actually for Windows Phone 7 as well. It wasn't in the Windows Phone 8 SDK. But that one is a kind of .NET API. There's nothing wrong with it. It's it's fully tested and works and it's great. But the better one is the windows.web.http, which is the Windows Runtime API. So just make sure when you're using it, you resolve to the right type. And we recommend, in most cases, you're going to want to use windows.web.http. In simple usage, like getStringAsync, they're the same, but as soon as you get more complicated, their usage differs somewhat. If you want to go or get a bit more complex, and you want to get the full response, instead of getStringAsync, you call getAsync, and you'll get back an HTTP response message. And that allows you to go in and look at headers and status codes and get the stream of the content, or get the here we've got an example of getting the text with response.content.reader string async. But it allows you to get at much more details and information about that request than you can with the simpler usage. Loads of better information on that. Here's an example of reading the response headers. So you call client.getAsync, and then for each header in response.headers, well, we're just dumping it out in a text file here, but you can have a look at the response headers to get a bit more information about what's coming back. And when you're on sending out, you can write out request headers. We already saw an example of this with the try parse add for a strongly typed header, but this is the full list. So, accept encoding, accept language, you can read the full list there. I'm not going to read down them all. So all of these, this is the new way. They're strongly typed header properties that help you make sure you get the syntax right for setting these things. Actually, I'm gonna skip this. It's in the downloaded code that you can download because I just want to keep moving to try and keep on schedule. Because I want to move on. Oh, just before I move on from HTTP client, I showed you some fairly simple stuff here, but actually it is a whole pipeline, and you can plug code into different bits of it. So retry filters, those purple blocks in the middle are modules that you can code yourself and plug into that HTTP client pipeline. You can put those orange purple ones are filters that you can put into the pipeline. The one on the right in the grey box, the HTTP base protocol filter, that is also a filter, and it's one that's given to you. And this one is actually how you turn on compression. Please do this. Always do this. There is no reason for not doing this. If you don't do this, this is one of those things where you are being a bad citizen. You're creating an app that's not being friendly to your users. If you're pulling stuff over the network, make sure that you say to the server, I accept compressed content, which is how you do it here. HTTP base protocol filter. You set the .automatic decompression property on that to true. That means you're saying to the server, yeah, I do compression stuff. It will, if the server supports it, which it may not, it will then compress the content and send it to you compressed. And then, as it says, it will automatically decompress it on receipt. So that means you're sending less stuff over the wire. Putting credentials onto it as well. Here's a password credential object. You can set that and put that onto the server credential or proxy credential properties of your HTTP base protocol filter object. And then, to use it, when you new up your HTTP client, just pop that into the constructor. And away you go. And this all ties into this subject of making smart decisions about data transfer. You know, just to drill home, I know I've said this a few times, but mobile devices work on bad networks. You know, it does. It's a fact of life. So you want to be aware of this, use compression, and also think about the amount of data that you're transferring. And actually, whether your data comes over as XML or JSON makes a big difference for that as well. So and don't transfer redundant data. So if you've got a service and you only need some data on the client, don't be lazy and send loads of stuff the client doesn't need. Send a nicely tuned package of information that's only what it needs and no more. I've got a nice demo that drills this home. It's a favourite of mine. I've used it before, and I apologise if you've seen it, but it's too good not to use again. So I'm going to open the solution for this. And what this is it's a service. So viewing the browser, it's actually a WCF data service. And this is the root of it. It's our old favorite, the Northwind database. So this is OData. So you can navigate just by going into, changing the URI. So we can go into customers, and it will give you a whole list of all the customers. You can get a particular customer by, again, changing the URI. So let's get the third customer. And also, that wasn't what I expected. What happened there? Customers. Because it's not it's actually a keyed thing. So if we want to get a particular customer, we go dash. Let's get ANATR. There we go. And you can also and there's all these cross-reference stuff into it. So if you want to find out the orders for that particular customer, you see this href there. You can actually kind of tells you how to change the URL in order to navigate through the relationships in the database. So it's super flexible and really good for clients to be able to dynamically navigate through relational data. So that's our service. But over on the client, now I'm just going to run it. It's a boring UI. but it's going to call. The interesting thing about an OData service like that is you can get the data in different ways just by setting request headers. Say, okay, I'm cool with Atom, or I want it in JSON. So first of all, let's do the OData Atom, and it's hit a breakpoint. It's made a call using our friend HTTP client, get string async off to our local host on port 1494. Oh yes, that's so beautiful. And we've got our payload. If we look at the payload, it's actually all that Atom feed XML we just saw in the browser. There we go. So that's all the data. And I'm interested in the size of it. So I've just popping up a message box. As you notice, this is a Silverlight 8.1 app. Received payload 28K, so that's the first one. Do it a different way. We call the same service, but actually we've put this application data, JSON, OData equals verbose header on it. So this time, it's coming back as JSON, but it's the verbose format, so we've still got all that cross-reference stuff so we can navigate the collection, which is nice. Well, might be nice. But the size of it is 15.4, so it's a bit smaller than the Atom feed. But now we can send application JSON, but not the verbose form of it. And this one is 8,000. This is the same data. We're just getting the supplier's data from the database. It's exactly the same data, although this now doesn't have the cross-reference stuff. And the final one, hitting the right button, is the same thing, but I've actually zipped it on the server just for effect so that we can see. That's what it kind of looks like. And that one is 4K for the same supplier's data.
Is that JSON or XML?
That's JSON, but also using compression on the wire. So it's compression and JSON REST.
Okay.
And just to drive home, if we, just to drive this home, if we go on a 2G poor quality network, because this is really a very small amount of data, and to count the seconds now on this really poor quality network to do the most compact thing, we go 1, 2, it was about 2 seconds, okay? And now do the other one. 1, 2, 3, 4, 5, 6 seconds. And that's a tiny amount of data. So that just really drills home to you the importance of using the right format on the wire.
It is a great demo.
It's nice, isn't it? Yeah. So that's just a confirmation of that. Wire serialization format makes a big difference. In network awareness in your apps, again, there's lots of APIs that help you to find out information about the network. First of all, you can get information through the network information.get internet connection profile call. That gives you back a connection profile object. First thing you need to do whenever calling it is check if it's null. If it's null, you're not connected to the internet. So that means you've got no network. And then you can also, there's lots of properties on it. So you can find out whether you're on wireless LAN, is WLAN connection profile. You can find out if you're on data roaming. So then if the internet connection profile is W1 connection profile, that means we're on a cellular network, and then you can drill down. I'm looking at the middle method here, and you can go and get the connection cost, the internet connection profile.get connection cost, and that object has a roaming property on it, so you can find out whether you're currently roaming. So this is good for making good decisions about being kind to your user, not trying to do big data transfers when you're on a roaming network. And there's also the network information.network status changed event, which you can show at the bottom. You can hook that and get an event firing when the network status changed. So again, you kind of hook that event and then do these other calls to find out a bit more information about the network you're currently connected to. What does this tie into? Well, there's this thing called DataSense, which is a set of components designed to help both your end users minimize their bills, helps mobile operators reduce their consumption and connectivity, and helps third-party developers build smart data-consuming applications. It's a whole suite of stuff. There's apps in it which the end users can use for looking at which apps are the hungriest and have transferred the most data. So again, another reason for keeping your data transfers compact, because if you don't, your users will see it and they might uninstall your app. And it's also a browser optimization service, so there's a kind of proxy that will send compressed content when you use the browser. Wi-Fi hotspot mapping to help users connect to cheap free Wi-Fi services. And part of that also is you as a third-party app developer can build data-smart applications. There are three kind of scenarios. The content streaming app, where it's a bit like Netflix or Hulu, where you've got content streaming all the time. A file sharing app, well, OneDrive or Dropbox, but actually the background file transfer service is probably a better way of kind of transferring files. And then a Wi-Fi only app, where you want to allow your user to do some syncing or something, but only when you're on Wi-Fi, not when you're on a cellular connection. I'm just going to look at the first one of them, which is the content streaming scenario. Again, it's our network information.get internet connection profile API. You need to find out, are we on a wireless LAN? So you call if internet connection profile.is WLAN connection profile. And then, if it is, you can get the connection cost of that profile. Find out check it's an unrestricted network cost, and if all that is true, we know we're on a free Wi-Fi, and hey, you just go away and stream away, and it's going to be good for your users. If you're not, if you're on a wireless WAN connection profile, then you're on cellular data, well, then you might want to put up a prompt to the user, say, do I really want to do this? So this is about being good to your users. This is the W1. Here you want to check, going on from where we were on the previous slide, get the connection cost. Look at the network cost type. If it's a fixed network cost type, then you can look at these ones at the bottom if statement there. If it's over the data limit, this is where you've got the data smart is activated. If it's over the data limit or approaching the data limit, then you know that they're close to exceeding their data allocation on their data plan. So then you want to say, okay, I'm sorry, you haven't got enough you haven't got enough capacity left on your data plan. I can't do what you want. You need to connect to a free Wi-Fi service. So it's all about information and being good to your users. Right, I'm going to wrap up with identity and authentication. I'm going to keep this short, although it's an interesting topic. The thing about identity and authentication is a lot of apps need it. It's if you've got a third-party app, a lot of them you can just run them and apps run and they don't need to know who you are. But as soon as you get into the idea of allowing people to personalize the alerts that they want to see, like that football, soccer, whatever. If you want to know, Manchester United is your team, you want to get alerts when anything happens to Manchester United, well, sure. Then your back-end service needs to know who you are. That means you've got to sign in. You need to have authentication. So a lot of apps need it. But the paradox of all of this is that obviously users don't like signing on. And if they do have to sign on, you want them to sign on once, and then your app needs to remember it. So you're not asking them to sign on every time that they run up the app. So this is what you need to do. And there's certain APIs in Windows Phone 8.1 that help you to handle this situation. First of all, a little bit of secure storage. I'm just briefly going to mention this because we talked about this yesterday in the data session. But the Credential Locker API is if you need to store credentials on the phone in local storage, this is what you need to use. And we already covered this in session 9 data, so I'm not going to say too much more about it. It is secure. It secures they're secured from other apps, and the best thing is as well they roam. So if you have the same app running on different devices, they can these credentials are stored once on one, and they're available to where your app is running on the tablet or on another device. This is the API. You new up a password vault object, and then you store in that password vault password credential objects. And to get them out, you can new up your password vault, and you interrogate. There's various methods for pulling them out of there. We covered that before, so I'm not going to say anything more about it. I want to say a bit more about this, though, the WebAuthenticationBroker. This is a component that really takes the pain out of authenticating against services that need OAuth 2 authentication, such as Facebook, Twitter, and a good number of others. Many apps you need to connect to these online service providers for doing social networking kind of features. So you're using their REST APIs to interact directly with their services. But the other thing about this actually for users, even if your app needs to store my soccer app, you want people to authenticate in some way, we could have our own authentication service and make users log on to that. But that would just be yet another username and password that user has to remember. And you know how it is. You have half a dozen of these things, and you can never remember what the password is. Or you use the same password on all of them, which is kind of defeating the purpose of things. much better, unless you really need to have strong authentication for a security point of view, is if you simply want to know who the user is in a unique kind of way, allow them to authenticate against a social network and give them a choice. Say, okay, you can authenticate against Twitter or Facebook, or which are services they use consistently. They authenticate against them, and you're just kind of borrowing their authentication service as a way of identifying users for your service. Then you can send their Twitter username or something back to your service and store your personalization settings against that. So the typical OAuth flow is you've got your online service, the app makes the authorization request, then the online service will pop up a web page with a username and password. The user has to authenticate against that, enter their credentials. Then the user decision goes back to the online service. The online service authenticates that, says, yeah, you're cool, and it sends back a token to your app. And thereafter, the app uses that token whenever they want to call back into that service. It's complicated to implement, and you have to have an embedded web browser control, which we don't want to do all of that. It's hard to implement, and has got a lot of other problems as well. The solution is the Web Authentication Broker, where you can authenticate easily and support single sign-on, which we're not going to cover. We'll cover that in the enterprise session this afternoon. It's very simple to use, and what we've effectively done is taken all of that bit and stuck it into a component. So the way you use it is just actually, well, the way on the left, again, this is one that differs between big Windows and Windows Phone. So on big Windows, you new up your web, you just call WebAuthenticationBroker.authenticate or async, and you wait for that. It's an awaitable method, and then you handle the response. You look at the response, and then there's a get token method. On Windows Phone, it's one of these and continue methods. You call WebAuthenticationBroker.authenticate and continue, and at that point, your app suspends. And we transfer control over to the shell component, which handles the authentication for you. And then when the authentication process has completed, it will reactivate your app, and you need to handle that reactivation, which you do like this. In the onActivated method in your app.xaml.cs, you'll be looking at the args that have come in and say, is this a Web Authentication Broker continuation event args? Takes a deep breath. If it is, then first of all, we got that standard logic, which is all the rest of this page is standard stuff that you tend to have on all of these activated events. This is where it gets interesting. You then redirect at the bottom. You navigate to the type of my page where you made the call. Whatever my page that does auth is the one that made the call to the Web Authentication Broker in the first place, where the and continue method was. So you want to navigate back to it, and then you need to pass that Web Authentication Broker continuation event args object that was sent in over to that page, so it can look at the response to find out whether it actually worked or not. On the page where it happens, you've got that property which we've called continuation args, which is of the same type as that activation event args. And in there, you would, in the setter, as we've shown here, you would call some code that continues, picks up exactly where we were with the Windows after that calling the async method. So at this point, you look at the web.authentication result to figure out whether the authentication was successful or not. Okay, a very quick demo for this. I've got in here, I've actually got, again, the SDK sample, which I'm not going to show, which has got really cool code for how you use this to authenticate and call services for Facebook, LinkedIn, Twitter, Flickr, or loads of stuff. But I'm just going to run my own just to give you experience, show the experience of it. I think we're done with all that kind of stuff. The main page, it calls authenticate. Let's just look at the code behind that. Button click calls this authenticate method. Go to the definition of that. This is it. We've got some, I've already been to Twitter, dev.twitter.com, and I've got myself a client ID and an API secret, which I defined further up in in statics. And then you have to give it some URIs, which again I've registered up when I went to dev.twitter.com. But then all you need to do is call this authenticate and continue method. So let's just go ahead and do that. And after that, it will suspend my app. Have I not got a network or something? What's going on here?
Are you still on the 2G network that...
Oh, man. You're so... Right.
There we go.
Let's just do that again. Thank you so much. I was thinking, what? Okay. It's really super powerful, that, isn't it? And it kind of gets in your way sometimes. Are we actually... anything happening here?
Authenticate, yeah.
Doesn't look like it, does it? No.
Yeah.
Yeah.
Okay.
Yeah. And then... oh, okay. Well, there you go. This has failed with a unauthorized response to unauthorized.
Oh.
Oh, okay. Well, I don't know. It's the way on that one. I shall have to... we're out of time, so unfortunately I'm not going to sit here and debug this. I will scratch my head a little bit in the break and figure out why that worked. It didn't work. It worked this morning when I tried it out, but there you go. That's the live demo gods for you. So, thank you for that. Yay. Yes, there was... there's always going to be one. Right. There is an SSS mode, which we're going to look at in the enterprise session this afternoon. I'm not going to talk any more about that. So this is cool, particularly for enterprise apps, where you can actually bypass the authentication completely. You've got your own service. It's a really cool way of having a suite of apps share that authentication. Right, so I showed you how to easily build a cloud backend with AMS. I showed you briefly how to use the background transfer API. HTTP client for HTTP networking calls. Briefly mentioned Credential Locker, and then I failed to demo the WebAuthenticationBroker. Loads of cool stuff there. And all I can say with that is go and enjoy networking Windows Phone 8.1. All right, we're going to take a little break, and then we're going to the next hot topic is...
the best one.
The best one, in your view, is tiles and notifications and Action Center. So loads of cool stuff in that. We'll see you in a minute.
And welcome back to Building Apps for Windows Phone 8.1 Jumpstart. I'm Matthias Shapiro. I get to cover this session, and this session is actually one of my favorites. We're going to cover Tiles, Notification, and Action Center. There is an enormous amount of information to go over, and to my excitement, we're looking at a lot of information that is almost everything in here is going to be Windows Phone universal, from our notifications to our tile, pushing our tiles out and launching our tiles and toasts. This is a really hugely converged story on Windows and Windows Phone. So let's get started, because we need to go fast, because there's a lot in here. We're going to cover tiles and notifications. How do tiles enhance the Windows experience? This is a little bit of information, just so you know. Tiles are really important, and we're going to tell you why. We're going to go over the tile template examples. There's a lot of them. We're not going to cover every single one, but we're going to cover some of the terminology that we use with tile templates, and where to get more information about them. Then we're going to look at sending notifications. How do we send notifications locally? How do we send notifications through a push notification service? And then we're going to look at managing our notifications with the Action Center. The Action Center is new to Windows Phone 8.1. And in addition to being just a fantastic experience for our users, we've also created, it also has an API, which makes it a fantastic experience for developers. So getting started with tiles and badges for Windows. And I say Windows, when I say Windows, I mean Windows and Windows Phone. This is a converged platform fully. So first of all, what are tiles good for? Tiles are the defining Windows experience. We've got tiles across all of our screens. They are the initial interaction point for applications, and they really do drive user engagement. You want your tile pinned up on the start screen. You want the user to see it first thing on their Windows machine, on their Windows Phone machine. And not only the tile, you want to have a live tile, because the live tile brings the latest information, it drives user engagement, it really brings your application to be alive even when it's not running. And as such, it's an essential piece of the Windows brand. So if you're going to integrate your application into the Windows brand, you really need to be thinking very seriously about tiles. This is a quote that we've used when it comes to design. The quote was, it's, "The alternative to good design is not no design." You can't have an application with no design. It's either going to be good or bad. And it's the same thing with a tile. You can't have an application without a tile. So give your tile some thought. Make sure it's a good tile, because you can't have no tile. A little bit of information about users and their tiles. We've done some analysis of our top applications and how users rate them and what users use them for. And believe it or not, the full functionality tiles are the #1 driver in high app ratings on Windows Phone. And this full functionality basically means that you've got a tile that's live, and it can be used as a small tile, a medium tile, or a wide tile on Windows Phone. That is the #1 feature that makes users happy. And interestingly, another one of the following close behind, I think #2 or #3, highly sought after feature for Windows Phone users is a secondary tile. And that's a tile that pulls the user into some sort of a deep link inside the application or specialty case inside the application. Users want their tiles to take them to exactly the information they want. And so you can do that with secondary tiles, and they really love it. Okay, so we got a lot of tile types, and the tiles are cross-platform. With Windows 8.1, we have small tile types, medium tile types, wide tiles, and then the giant, big, huge tiles. This is the only part, that big, huge tile is the only part that isn't cross-platform. All the other tiles are cross-platform. And one thing that I'm going to call out, and we're going to see repeatedly as we go through this session, is that you see the Windows 8 tile types, and you can see that they're a little bit different visually than the Windows Phone tile templates. Well, these are the same templates. It's just that Windows Phone is rendering them in a way that just perfectly fits the Windows Phone style. You can look at all of these cross-platform tile templates. They're available at aka.ms/tile templates. So as you go through that list, you're going to see a lot of tile terminology in here. I want to call a little bit of that out so you can understand what they're talking about. The first piece of tile terminology is peak. A peak tile means that there's a second part of this tile, and it's going to be animated in. So you can see an animation on Windows, and then it's actually going to flip from front to back on phone. Block means a large number text, and so that's going to be the 3 here and there, or the 24 is the block. It's rendered differently on Windows than it is on Windows Phone. It's meant to be defined, give the best presentation on a tablet versus a phone. So then we've got image collections, and this is literally just a list of images that you're pointing your tile to. Yeah, and I guess that's all of the tile terminology. As you can see, again, rendered differently on Windows and Windows Phone. It's been designed specifically for the form factor that it's being displayed on. So if you're building your first tile template, you're going to go to your appx.manifest, where you can set up a primary tile in your visual assets section. This is going to be the tile when the user presses and holds your application in the app list, and it comes over and it gets pinned to the start screen. This is what your where your tile is going to be defined. You can give it a default size, you can give it a background color, and you can just give it the logo that it needs. The tile sizes are what you see here. The one that's a little bit confusing is the square one, which is 71 by 71 for Windows Phone, I believe, and then 70 by 70 for Windows. The square one is 150 by 150 across both platforms. Wide is 310 by 150 across both platforms. And then large, available only on Windows, is 310 by 310. So the way we create or update a tile is with a tile object, a tile XML object. And it looks a little something like this. You've got a tile, and inside the tile it has one visual, and that defines multiple bindings. And the bindings are for all the tile types that exist, that your application creates. And so there might be a medium tile type and a wide tile type and a huge tile type. And those are all gonna be 3 different bindings inside of this visual. Now you can define that huge tile type in Windows Phone. You can take this whole XML, you can send it to Windows Phone and to your Windows application. The Windows Phone will just ignore anything it can't use. We also have these badge XML, and the badge is, I thought I had an example here. No, we'll get to that in a second. The badge XML is just like the tile XML. It's got a badge, you've got a value, and and we'll get to that in just a little bit. So tile XML schema defined a little more clearly in this table. Like I said before, you've got your tile, you've got your visual. The binding defines a single tile template, and then inside of that, you're going to have texts, which gives you the different text elements inside of your tile, and image, which defines the different image sizes or image elements in your tile. Your images should match the size and shape image requirements of the template. That's just one thing you should do for a good user experience. So if you're creating a tile inside of your application, here's how you do it. You create an XML document, you load the XML that you saw previously into it, and then you create a tile notification with that XML document. Then you can use your tile update manager and create a tile updater and just update your tile using that tile updater and the tile notification that you've created. So let's look at a demo on creating those tiles locally. Okay, this is a universal application, as you can see here. We've got the Windows 8.1 version, we've got the Windows version, and we actually have the code to set our tiles is all inside of this tile setter, which is in our shared project. So this is purely cross-platform right here. Go ahead and run this. I'll go ahead and run on the device. Open it up. Nope. There we go. And here it comes. Okay, we're going to create a medium-sized image, and I'm just going to draw a big smiley face. That's our medium image. We create a wide image. This is a horrible smiley face. Okay, and then we'll just say jump start. We're done. We can hit update tile. Oh, and I completely forgot to pin that tile to the front, so let's go ahead and do that now. Nope. Hold on, sorry. I gotta figure out
what its name is.
Yeah, I must have named it something other than that. So let's see here. I'm gonna stop this and find out what I have named this. Local tile demo. Of course I did. Of course I named it something different than.
It's a danger of running it on a real device.
Right. Pin to start. There we go. Okay, and we can actually see. Move.
You need to get that up.
Oh, there we go.
Yeah.
We can actually see. Oh, come on. This is just. I'm sorry. I'm sorry, folks. Okay, there it is. So we got our tile, and we can change it, and we're actually going to have to run it again because, okay, we're just going to do squiggles this time. Jump start, flying through it, update that tile, and now if we go back, we should see that tile update. Am I missing? I must be missing a piece of code. Okay, so that doesn't work, so let's find out why. Sorry. Okay. So we've got our tile rendering, and if you're interested in how to render a piece of XAML to a tile, that's all in here. Yeah, and that's the piece we're missing right there. Is I actually have code to go in here. So I'm going to call that tile setter that I have in my shared project. Dot create tile. We're going to give it my medium image path and my wide image path, which I've created when I rendered that XAML out. And then we're going to take the title text.text. Okay. And we'll jump into our tile setter and we'll look at exactly how it does that. It creates that XML document. It takes the local path for the medium tile image, and it takes the tile text, and it creates that first binding, that medium binding. Then it takes the local path for the wide tile image and the tile text, and puts that inside the wide binding. And then it loads all that XML up. And then we need to add our tile notification. New tile notification, tile XML. There it is. We'll do our tile updater. Update equals tile update manager dot create tile updater for application. You can see that we use this updater. We're going to enable notification queue to false, and I'll talk about why we do that in just a second. And then we update our tile with a new tile. Okay, now we're going to run it again with all the code in place, and it's amazing how much better that works. Okay, squiggles, and more squiggles, and text. Okay, there we go. Update our tile. Back to the home screen. And you see, we've got the tile updated. Woohoo. And you see, we've got a medium-sized tile and a large tile. And we can't change the small tile this way. It's just a static image. So that works. And I was hoping to have enough time to show it on Windows. But in the interest of getting all of this information out, you're just going to have to trust me. It works. It's cross-platform. We're actually using, as you saw in the shared, we're using the exact same code to send out all of our tiles. So, okay, the rest of this will go smoothly. You can use the notification extensions. At the moment, I believe these notification extensions are, this is basically just a simple helper class that gives you all of that textual, the XML information in an easy to use way.
Yeah, it saves you having to work with raw XML.
Right, yeah. Which can be a bit cumbersome.
Yeah.
At the moment, I believe it is Windows 8. It's open source, I think. You can go grab it and turn it into Windows 8.1, but I know they're also working on making sure that it comes out for Windows Phone 8.1. Okay, notifications. Notifications are the way that our application is sort of always on. We can always be sending new information to the user through the start screen, through the tiles, through toast notifications, and then, as we mentioned previously, through raw notifications that are waking up a background task. So there are lots of ways to display notifications. We have tile notifications, badge notifications, toast notifications, and raw notifications. The tiles we've already talked about. The badge has a little black logo up in the top right corner for Windows Phone. Toast is just like a text message coming in, and then the raw notifications, we can handle any of these in a background task, but the raw is the most valuable for a background task because we can just send an arbitrary string and just do some stuff with that string.
Yeah, it's cool.
So for toast notifications, we need to make sure we've enabled our toast notification in the manifest. Otherwise, we can't send them.
Oh, if I had £1 for every time I'd forgotten to do that.
Right.
Sorry, $1, whatever. You get
And then we can send our toast notifications using this toast XML. And so you see this, the whole XML schema is how we send all of our notifications. Then the user taps on the toast notification to launch the application. In Windows, we have a lot of different kind of toast notifications, and in Windows Phone, we do not.
We have one.
We have one. You have this type of toast notification. You could actually take some of the toast notification options that they have in Windows, and they're still usable in Windows Phone. It's just going to render the exact same way. Whereas you have options in Windows, you don't have them in Phone. So there's lots of ways to send tile notifications. You can set a scheduled notification for tile or for toast, and just basically say, okay, at this time I want you to update the tile. At this time I want you to update the toast. You can update notifications periodically, and this is usually for a tile. You just pull from a URL. Maybe it's an RSS feed that's just RSSing a bunch of XML for your tile notification. Just pull from it every half hour, every hour, 6 hours, 12 hours a day. This is really great for information where you don't want to build this big complex backend that's always sending push notifications, but you want your application to be updated with some frequency. You can do local notifications, so you can update within the application, either the foreground or the background. And then you can use push notifications using WNS push services. And we're going to dig into that one big time. Scheduled notifications run this way. We have our application. And our application, inside of our application, we use the scheduled notification API. And once we use it, it goes to the system schedule queue. And the system is checking that schedule queue, checking that schedule queue, checking that schedule queue. And when it sees a notification that has been scheduled, it'll send an update to the tile or send an update to the toast. Using that looks like this, where we just use the scheduled toast or scheduled tile notification API. We give it that XML doc that I've been showing up on the screen, and then we give it a time when we want it to update. Send that to our notification manager, and we just add it to the schedule. Now, a point of note for this is this is not going to work in a super granular manner, and so you can't use this to do something like a minute-by-minute alarm. It's going to the system pulls all these schedules together, and it hits that queue in a way that makes sense for the resources of the application. Maybe you're running low on battery and you have really poor signal. I guess signal wouldn't matter, but you're running low on battery, and so it's going to hit that schedule. It's going to decrease the frequency with which it hits that schedule queue. Periodic updates are going to work a little bit like this, where our application goes to the Windows System Services and says, hey, I want a periodic update every half hour, 6 hours, 12 hours. At the increments you saw before. And then it will go to the tile and badge updater APIs, and it's going to hit that process with a certain amount of frequency, send that, and then go to an HTTP request looking for an XML payload that it can then render into the badge and updater APIs. And then it'll pull from that service and update our tile accordingly. We can also do periodic updates the easy way, which is the codeless way. And for that, we open our package.app manifest. And there's a little drop down where we say, I want it to update every 6 hours. And I want it to go to this tile RSS feed. And then we don't have to run any code, and it just runs, it works, and it's going to use that RSS feed and tag it every 6 hours looking for new tile information. We also have local updates. We can do tiles and badges using the local updates. Tiles, badges, and toasts, I believe, using the local updates. That's the code that it looks like, and we just go and grab our badge update manager, our toast update manager, our tile update manager, create a badge updater for the application, just like you saw in the demo, and it just goes and immediately makes that update. There are some limitations on which kinds of updates we can use for which kinds of notifications. And you can see that here in this table. Tiles, we can use scheduled toast, periodic, or push. Badge, we can only use local and push, or local, periodic, and push. Toast, we can use everything except periodic because we don't want you sending a toast notification every half hour. That's just not a great user experience.
Why not? Yeah.
Right.
Annoying.
I dream of a world where I have 100 applications sending me a toast notification every 30 minutes. And then the raw notification only comes in through push.
Oh, you could use that to pretend you have loads of friends.
Right. It's the lonely application.
Yeah. You see, you invented it already.
Now, you saw that I turned off notification queuing in the demo, and here's what notification queuing is. Our tiles can cycle these notifications. That's up to 5 notifications in a queue. And so if you just add these tile notifications one after the other into the queue, and that means your tile can convey an enormous amount of information. It can convey up to 5 different fully templatable tiles, and maybe these tiles even flip from front to back. And so the tile then can become, with the queue, a real window into the information inside of the application. You can, once you have that queue in place, you can replace tiles in the queue or set expiration for tiles. So in the case of the football scores that Andy was showing, maybe you're going to show those football scores up on your tile. But you say, I know this game ends at a particular time, which with football I don't know how that works because I'm American. But you say, I know this is going to end at a particular time. So after that time, drop all the scores off of the queue and only show the end result. That's the only thing they're going to care about. So push notifications, this is particularly exciting because in the world of Windows Phone 8 and Windows 8, we had 2 different push services. We had the WNS service and the Microsoft Push service, MPS, I believe, MPNS service.
MPNS.
And now we do not. You can still use the MPNS service. It's actually just a shim around the WNS service, so it actually works a lot better than it used to.
I'm talking about that in the last session.
Okay.
The Silverlight session. We were
Perfect.
talking about MPNS versus WNS.
Okay, so the last session, which is tomorrow.
Session 23 tomorrow.
Just wait for that. We'll cover that. What you need to know right now is that all of our Windows devices are on the WNS service. And so that's one service across all Windows devices, one process to register an application for push, one tile template that you can push to Windows or Windows Phone applications. So I know everybody's been waiting for the architecture diagram, and here it is. Our Windows Phone, we've got our Windows Phone application and our Windows Notification Client Platform. Our Windows Phone application will communicate to the client platform and get a channel URI for that application. It's going to register that channel URI with our cloud service. And then our cloud service, when the time comes, is going to send that push notification to the Windows Push Notification Service, which is going to communicate to the Windows Notification Client Platform, which is going to update our tiles or badges or whatever accordingly. Setting up an application for push is really, really simple. You right-click on your phone application, you go down to Store, you associate that app with the package store, and then there's a wizard that's going to walk you through the rest of it. You do need a store.
Actually, it's the same thing you saw in my Azure Mobile Services.
Exactly.
Where it pops up.
Exactly the same process.
Asks you for your my developer account.
Yep, that's what I'm looking for. Yeah, so you do need a developer account in order to associate your application with the store, but you don't even need to go to the service. You can do this all inside of Visual Studio. And then you simply associate your application with a name that you have reserved, or you can reserve a new name right inside the wizard. And then you click the Associate button, and all the associations are made, and you're ready to go. That store association is going to be stored in this package.storeassociation.xml file, and that's where you can go to get some of that information. So here's the code for getting that channel URI, which you're actually going to see in the next demo. It's really simple. We just do an await for our push notification channel manager create push notification channel for application async. and then we can save that notification. This is just a sample method for saving that notification to our own personal service. Then we can listen for when we've got a push notification, and this is how we would listen for that notification inside of the foreground of our application. Okay, so sending push notifications, there's a sample project for sending push notifications, and that's at pushtestserver.azurewebsites.net/WNS. We'll see that again in a second.
Anybody can use this?
And anybody can use this. I actually have a link to the code, so you can download the code for this service and use it later on. Or you can use the Azure Notification Hub, which Andy mentioned in the previous session. This is for cross-device notification. It's a really powerful system. Highly recommend you go check it out. But what we're going to do in the demo is use this notification simulation engine. And this is an incredibly powerful engine that we have built into our emulator tools. And we're going to pull it up and kind of show you how to use it right now. Okay, so I'm going to open up my push notifications application. Oh no. And close the other one. We're going to run this one in our emulator. We have our 512 emulator open, so let's make sure we've got that set appropriately. And I am actually you're going to see me pull up my demo script because I am going to be using a lot of different notification types, and I want to make sure that I have those in place. So a little peek behind the scenes here. This is also a universal application. And what you see, we're in our push handling helper. So this is actually, right here. This is where we're going to get that URI association as soon as we run our application. We'll take a look at it. Okay, so we're going to get our push channel, and it's waiting for that push channel. Oh, this is probably another one of those ones where I thought it would be a great idea to do some code live. So, if I'm not mistaken,
yes.
Yep, here we are.
Certainly.
Push notification channel helper. No. Hold on, I'm sorry. I'm going to have to pull up my demo script here. Okay, we're just gonna push channel click. Okay. Okay, so we'll try that again. Okay, now we get the push channel, and it actually gets the push channel. We can walk through this. So it's waiting to get that channel. Okay, now we've got it. And we can send it to that text. And there's our push notification channel.
It's actually really long, isn't it?
It is a really long
URI,
string.
Yeah.
So we want to simulate these push notifications, so we're going to turn simulation on. And we're going to refresh the application. And I think I might actually need to reinstall the application in order to get this, in order for that enabler to see it.
Yeah.
So, uninstall. Yep. We know that works, so we're just going to take it off. Run the application again. Get our push channel again. You see it worked a lot quicker this time. If we hit refresh, okay. Now we've got our app ID, we've got a URI, we've got a notification tile in here. We've got everything we need to start making, to start sending those test notifications.
And let's be clear, in Windows Phone 8 days, you had to you had to write a custom service in order to test this.
Yeah.
Write your back end in order to test how the client reacted.
Yeah, testing was not the happiest thing in the world in Windows for push notifications. It's gotten a lot better. So we're going to change our template to the tile square peak image and text one. That one there, and it gives us some sample that we can use.
That old favorite.
Right. And I'm going to paste into here, and you see I've actually got a little push image that I'm using. So before we send this, let's make sure that we have this pinned to the start. I really should have named this AAAA tile push sim. Okay, so that's what our tile looks like right now.
Awesome.
But if we send this tile notification, push it to the device,
Yay.
then we've got the push works for our medium-sized image. Now let's send a toast notification. Yes, I want to overwrite. I'm going to send this toast notification that we have here. It says, tap on me, I'm a cute birdie. Right there, we'll send the toast notification out. And there it is, and if I tap on it, it takes me into the application. You can actually see that I've been saving all of my tile information as it comes in. Now this is only working because I'm debugging, right? So the application has not actually has not suspended, and I'm still all of my methods are still running. And we can take another look at a badge notification. And the badge is nice and easy. We can have a number in there. And we see our badge show up. There we go, right there.
Only on the front of the tile, not the back.
Right, right. And we can actually use some of these. Well, we'll get into this right after this demo. But the badge has a number or any number of these sort of messages that work across platform. Not all of them work on Windows Phone, but we'll look at that.
Because we only had numbers in Windows Phone 8.
Right, in Windows Phone 8 we only had numbers, and if you need to get rid of a badge, you send another badge with the value of 0.
Yeah.
And that'll get rid of the badge on your application. So this is a really powerful tool for testing your notifications. I don't know. I thought it had some slides around badge notifications and toast notifications. And I don't know where those are, and I'm a little horrified at myself right now. Okay. Well,
take the knife to them.
Right. I must have cut that in the interest of time.
Yeah.
But that's okay because with the time left, we can spend that looking at Action Center, which is really
just as exciting.
Really exciting.
Yeah.
So, the Action Center user experience. Was a hugely important request from our users. And so we've implemented it in Windows Phone 8.1. For the Action Center, you can send up to 20 notifications, store that in the Action Center per application. And those notifications will be persistent for 7 days or possibly shorter if you start running out of room. Or the users can chase a notification by tapping on it, and that's going to remove it from the Action Center. It'll open up the application. You can remove a group of notifications, or you can remove all of the notifications. This is available on Windows only. We do not have an Action Center on Windows Phone. Windows Phone only. We don't have a notification center on Windows yet. But in addition to that great user experience, we also have a great set of APIs that developers can use to manage the Action Center experience for their users. Developers can remove one-to-many notifications. They can tag and group these notifications, and using these tags and groups, we can replace notifications. With a new notification, we can delete notifications. We can set expirations on those notifications, and we can even send these ghost toast notifications. And so, the sort of classic example for this is, in Facebook, you want to know when somebody maybe tags you in a photo, but you don't necessarily want to know when somebody is when there's a giant group chat with 50 people and they're all saying okay. So you can send the unimportant notifications as ghost toast notifications. They'll show up in the Action Center, but they won't show up as an actual toast on the system. So it's a way of kind of streamlining the notification experience that your users have to become slightly less annoying. We can use tags and groups for replacing notifications. A matching tag and group is going to trigger that replacement. So the scenario there is you've got an hourly stock price. your price. You make sure that the replacement notification has the same tag and the same group, and it will update. You can do that. You can use those tags using. You can set those tags and groups using these notification properties here. The setting an expiration. A scenario here is maybe there's a limited time price on an item or some sort of time sensitive information. You can set an expiration date on those notifications, and when it hits the expiration date, it'll automatically take out a notification center. You can remove those notifications. The scenario here is maybe there's a sold out deal and it's just not relevant anymore. But let's take a look at how we do this inside of a demo. Okay, stop our last application, and we're going to run our Action Center. Now this is going to be particularly interesting because we're going to use that service I was talking about earlier, the Azure service for testing notifications, and we're using this one instead of the emulator one because this is
So I guess you have to turn that one off. In the
that's right. No, actually, I was going to run this on the device. That way, I don't have this.
Okay, yeah.
So yeah, if you do run a word of note, if you try to run and test your for real notifications, you got to make sure that your emulator notifications are turned off. Otherwise, they're gonna conflict. So I'm gonna pull up my demo notes on one side, and okay, here's my live device. Okay, let's get this started. So we've got our actions there. We're going to get our push channel URL. And you see, just like we had before, I'll run that. And then we're going to, when we populate the Action Center, what we're basically doing is just grabbing a bunch of data, using that data to create a pile of toasts that we're then going to put into our Action Center. So if I populate the Action Center here, you see hopefully that there's a little icon up at the top. Now if I pull the Action Center down, we have a group of notifications, and I can chase those notifications. It takes me back to my application. Normally I would do something like that, and you see that one went away. Or I can make them all go away by swiping to the side. So let's populate that Action Center once again, and watch and show how we can do these sorts of updates. First thing we need to do is I'm actually going to get a new, I forgot to save my channel URL. So go back up here, we get our push, and we're going to copy that channel URL value and paste it here at the top. Get rid of our quotes. Okay, and now we have everything in place to start sending out these sort of live.
So this is kind of the web version of the tooling you got in the emulator.
It is. It's a little bit more flexible,
right?
With options for toast delete, ghost toast,
okay,
that sort of thing.
Yeah.
So the first thing we're going to look at is replacing a tile. We're going to take a look at the tiles that we have in place, or the notifications we have in place.
Replacing a toast, yeah.
Yeah, replacing a toast. Populate that Action Center again so I can show some of this stuff off. Okay, so what did we put in here? Well, the first one is this toast is but a breath, a mere moment, and it is gone. And this one is a toast where we have used that that expiration API. So eventually this is going to go away. I think I have it set to 1 or 2 minutes. One interesting note is that it doesn't go away live. I have to close the Action Center and open back up in order to notice that it's gone. But you see, breaking news, kittens have full control in Action Center. Well, that's not right. Kittens do not have full control in the Action Center. Developers have full control in the Action Center. And so in order to replace that with the correct information, we're going to send this updated toast, and we're going to add, select the group breaking news and the tag correct me, because that's the tagging group that notification is set as. We're going to send a ghost toast because we don't want the user to know that we made a mistake. We want to kind of slide it there under the radar. We send this push, and you see it's updated live. It's pushed it to the top of the notification queue. Everything is good. So that's a simple replacement. We can update one of our notifications. And so if you can see in here, this is a stock application. Microsoft is at 100, Apple's at 3, Google's at 1, and we think Google's been doing a lot better recently. So we're going to bump Google up 400% to 4. Okay, there we go. We're going to do this as a normal toast, and we're going to use we use the stocks group and the Google tag. We send that push. Oh, nope. I see what happened there. We selected toast, and it gave us the boilerplate instead of the toast that I had actually. Okay, so we'll try it again. There we go.
Yeah.
And we've got that. That notification has been updated. And we can delete notifications. We're actually going to delete a whole group of notifications. We want all those stock notifications to go away. So we can go to toast delete. We're going to delete just the group called stocks. We go back to our application. We send that push. We see all of our stock notifications have gone away. And so the only thing we have left to demo is to show how the expiration that we sent on that last toast goes away. And if we make our Action Center go away, pull it back down, we see
you refreshed it.
Yep, we've now refreshed.
Expiration doesn't happen while you're watching it. Yeah.
Exactly.
Okay.
So that's how we can interact with the Action Center. It's a really powerful set of APIs for interacting with the Action Center. And if you want to use that push tester that you saw right here, here is the URL again, pushtester.azurewebsites.net/WNS. And you can also get the source code. You can get source code for a client sample of this application, or you can get the source code as an Azure sample of this application. You can try to write this down. I'm going to leave it up here for just a little bit. Or you can search for WNS notifications for Windows Phone on the code.msdn.microsoft.com, the code samples we have up there. That'll also show it. So that is it. Go forth and notify. Send those notifications. Build those tiles. Build those incredible notification-driven applications. And reminder before we go, we're going to take a meal break. It's going to be about 30 minutes, and then we're going to make up some of our lost time with what's coming up next, Andy?
Bluetooth.
Bluetooth
LE and NFC, cool stuff.
Okay.
Yeah. And then some contacts cameras. Then some camera, enterprise. We've still got loads of great stuff.
There's a lot of stuff coming up after lunch, but we'll see you then, or after meal.